So welcome back, and we have a lot to unpack here, so let's get right into it. Between flights 6 and 7, I had to do a bunch of repairs. Flight 6 ended up not deploying a parachute, and as a result, the aft section of the rocket had to be almost completely rebuilt. This is a process I'm pretty familiar with at this point, so it's not a major deal to get done. While a complete rebuild is a pain, it does offer the opportunity to improve the technology that I'm working with and fix problems that I've been dealing with on the rocket since day one, basically. One of which is the ability to set up and tear down quickly. This project as a whole is attempting to build and fly a model rocket that functions and operates the same as a full-scale one. Classically, a lot of these model rockets just go up, deploy a parachute, and come down. But in this context, we're trying to replicate not only the form, but the function. An actual Falcon 9 takes off as a 2-stage launch vehicle, deploys its second stage, and has its core stage come back and land. This is an incredibly complex problem. It's really hard to understate. In the process of all of these events, we have to have 2 flight controllers running in concert together. We have to have communication between them. We have to have launch systems on the ground that are able to manage this and supply the rocket with what it needs. And we have to have enough confidence to throw all this money into one object and have it go into the air and believe it's going to come back. In the process of learning, I've been flying just the core stage of my Falcon 9. It's a lot smaller than some of the multi-core rockets that I'm working up to, and the 2-stage version that is still in waiting behind me with all of its components ready to go. It's just I'm not ready to put all of my eggs in that one basket. Having more confidence is really important, so between flight 6 and 7, I made a bunch of changes to the software and to the hardware as well. One of those things is an improved umbilical. And adding the umbilical to the rocket would allow me to set up and tear down at the launch pad and do testing way faster than I have been. To make sure all these ground systems and flight systems work together in concert, we do integrated testing on the whole system together. And as a result, we end up doing a similar thing to what's done on full-scale launch vehicles, just like the SLS here. That means performing an umbilical release and retract test, or URRT. This is done on almost all real launch vehicles to confirm that the umbilicals that are supposed to disconnect right at T0 for liftoff actually do it. The umbilical's job on a full-scale launch vehicle is to supply power, propellant, or purge to the launch vehicle, and each of those commodities need to be severed right at the moment of liftoff. That T0 moment where we lift off is very critical, and we don't want to disturb the rocket as it leaves the launch pad. I dug into the software as well between flight 6 and 7 so that I knew what the cause was of the parachute not deploying. It turns out it's actually really easy to see the more you run hardware in the loop testing, because you can see all the events on the ground without having to ever fly it. And I simmed the rocket flying at least 200 times to confirm that everything I had coded actually works, and we run through every series of events. At Apogee, we're deploying a series of fins on the forward section of the rocket. These will stabilize it so that it falls more like a dart straight down towards the ground, and I have a controlled attitude on descent. This will be really important when we get downstream and we're trying to launch and land consecutively. After many rounds of testing, I was able to pinpoint the error, fix it, and of course, as always, it's just a small software bug. So with that in mind, I had the whole rocket integrated and ready for flight and went out to the launch site once again. I was treated with a great sunset and good cloud cover for this launch, and I think I got one of my favorite clips I've ever gotten of one of these launches.
Oh, come on.
He needs some milk.
And once again, the chute didn't deploy. So here we go again. I had a ton of confidence going into this launch, and one of the things about these type projects is they can be very humbling all of the sudden. You can go into things having really high confidence and just have it absolutely obliterated. In these type circumstances, it's really like a gut punch because you set everything up, you work really hard on it, and then when things don't go right, it's like your baby basically just fell out of the sky and died on the ground. I didn't want to let this failure get me down too much, and I pushed right back into rebuilding whatever was broken between flights and got things ready to go again. Of course, once again, the problem lies in the software, and looking at the data, while we're a little wobbly on takeoff and there's a little bit of over-tuning on the P-gain on one of the control axes, otherwise the rocket performed perfectly. It logged data throughout all phases of the flight, but looking at the data revealed the exact cause of the problem for this flight, and that is throughout the entire flight, it read that it was at 0 meters altitude, which means there was no sensing and no triggering of any of the pyrotechnics on board, which is a great test of the safety system on board, which inerted everything and meant that the rocket would not, under any circumstance, fire the black powder charge or legs or fins on board. But at the same time, it meant we crunched another tube on the aft section. I also managed to damage one of the IMUs on board, which thankfully I have spares of, and I was able to use most of the spare parts that I had on hand to get ready to fly quickly once more. And it turns out all I had to change in software this time is uncomment the sensor reading for the barometer. In my huge battery of hardware in the loop testing, I ended up removing the line of code that reads the barometer and told the rocket not to read that and instead read the hardware in the loop testing functions. While really minor, this makes the whole launch vehicle unable to do its job. It can't tell how high it is, it can't trigger events, and it just remains in its safe inerted mode. But it will ascend and it will control. So I did get great data back on the overall controllability of things. With everything ready to go, I built a new mission patch that summarizes my failure from the last one, and we went right back out to the field again for another flight. I had a few problems on the launch pad right before liftoff and had to troubleshoot some problems that ended up extending my launch window all the way towards the edge of having any light, but we were able to just barely get off the ground before sunset and got some good shots nonetheless. The control gains are just a little too high. They were tuned for a weaker rocket engine that had less thrust and as a result, less control authority. So while pretty minor, it is kind of cool to be able to see the rocket swivel and curve in flight as it's actively controlled. The fins and legs all deployed, although it's a little hard to see due to the lack of light, but I would consider this a very successful flight. As I build more confidence, we're going to be pushing more towards getting back on track on flying a two-stage vehicle. Looking forward, I want to try and do more deployments in air, like lighting a second engine to continue the ascent phase, or just extending the burn time and trying to fly higher while also collecting more data on the control system in different circumstances. We're getting pretty close to a two-stage flight, and I feel more confident in the software, which has meant I've reactivated my SLS program to be able to fly that on a software that I know will work. That has been getting a ton of work in the background to get it ready to fly, and I'm very excited to have that fly again. I'm at this point racing the actual Artemis 1 launch date, so hopefully I can pull that off, but due to work and editing these videos and trying to get more data from my Falcon 9, I'm not 100% if I can get that done right before the actual launch of the real thing. This launch has incorporated a ton of things I've learned and a lot of new techniques and hardware that I've been trying to develop. And all of that is basically now available on my Patreon. I have a shared drive where I link all of my 3D printed parts for these rockets. So if you have your own small scale launch system that you're trying to build up, you can build basically everything I have here. I offer all those parts for all levels of membership, and I really appreciate any support. I'm also looking at making the mission patch from this last flight into a sticker, as well as the next one, which I will be sending out for Fab as well. So patrons will be able to get the refresh of the latest new stickers to be able to have them shipped out as well. So yeah, thank you very much for watching, and I appreciate if you stayed this long. So I'll see you in the next one.